Right. My name is Magnus Kvalevåg. I work in Oslo at a company called Kvalevåg. What I'm here to talk about today is an awesome concept called stateful property testing, and one of the ways we are using it at my company to catch more bugs. Now, even though we are doing functional programming, we are still making stateful systems. And a stateful system is any system where one call is dependent on previous calls, or it has some internal state that changes over time, as with applications that store data in a database. And because of the nature of stateful systems, they can become really difficult to test with just example-based testing, which seems to be the most common way of writing tests, is when you have a system and you give it an input, and you check that the result has an expected value. But because there are infinitely many ways that a stateful system can be called over time, it can become really difficult to come up with all of those cases. So this is why we use stateful property testing, because it creates many of those test cases for us. And there exist some really cool examples of real-world usages of stateful property testing. My favorite one is from a database called LevelDB, which is developed by Google. And here they found a bug that only occurred after making a total of 17 API calls to the database, one after another. And this was done by letting the testing framework generate a bunch of operations that it then ran against the database, followed by verifying that the results were correct. And once it managed to find a failure, like using many commands, it also shrunk it down to the smallest possible case, which in this case was 17 operations. So stateful property testing isn't only useful for finding obscure bugs in stateful systems that requires a long series of commands. It also shrinks that series down to the smallest possible case, making it easier to debug afterwards. So what is it, really? Well, it's when you have a stateful system that you want to test, and you have some operations that you want to test running against that system. And these are what we call the commands, and they are randomly generated during our test. And we run those commands against the system, like so. And we also have something that we call a model, which is like a second implementation of your system, which we also run the commands against. And then the final step is to validate the results of calling those commands against both the system and the model. And most of the time, we do this by checking that the model and the results agree on what the return value should be. And if this step returns false, that means the test fails, and the commands are shrunk down, automatically filtered out, leaving us with the smallest possible case of commands needed to produce that failure. So it could be a little more complicated than the animation I showed, but it also could not be. I'll talk about the more complicated way, but I'll get to that. The three most important components of stateful property testing, that's the model, which is a high-level version of the system. And as well as running the generated commands against the system, we run it against the model, and then we compare the results for both of them. And the model is something that we define. It's usually just a simple data structure, like a hash map, but we also define functions for updating it to the next state based on which commands we run against it. And it's also the commands, which are the actual operations that we run against the system. And they are randomly generated, and we decide how they are generated and what the commands are. And if the test fails, then they are filtered out, like I showed you. Yeah. And the last step is the validation step, which is where the actual testing takes place. And this is where we could compare the state of the model with the result of the system for each command. And in an example-based test, this would be like the equivalent of a test assertion. But we run this for every command. So now I want to show you one of the ways we have used this at my company. Now at Kvalevåg, we make recruitment software for organizations that get a lot of applications for their positions, such as in retail or in the service business. And we have both applicants and recruiters that use our system, and we make sure that it's as simple as possible to hire candidates. But one part of the application process involves answering a questionnaire, which we have developed ourselves, and we codename it Formidable. And it looks like this. And as you can see, Formidable questionnaires are designed to be conversational, and we do this by specifying rules on the questions and having conditions saying that this question should be hidden unless this condition is true. And for building these questionnaires, we have another tool, which is the form builder, which looks like this. It lets us specify, create questions for the questionnaire with various types, and giving them a label. And also the second important thing is that we have behavior, something that we call behavior, which is the way we add dependencies between questions and making the forms conversational. And that looks like this. You can create conditions and make some other question depend on that condition. And this is what the form looks like again. So some fields aren't visible unless the values of other previous fields are a certain value. So we developed the form builder over a year ago and have only been using it internally so far. But we are now, however, also making it available to our customers. And thus, we need to make sure that it's bug-free and that it's robust and living up to our customer standards. We can no longer just ignore all the quirks and the bugs that we have lived with for over a year. So we added stateful property testing to the form builder. So let's step through this process together. And to start, we start by defining what are the commands we want to run against the system. What are the operations that we want to run against the form builder during the test? And I like to start things simple and add more complex behavior when I get the test up and running. And the most common operation is to just add a new question with the type and the label. So let's just put all of this into one command. So this will be our first one. And we can also delete questions. And we can add some simple behavior to the form, making it conversational. And now that we have defined what our first set of commands will be, let's find the invariants of the form builder. But first, what are invariants? How many of you know what invariants are? Could you raise your hand? That seems like maybe 40%. But invariants, those are the statements about your system that should always hold true. And they may be difficult to find sometimes because they differ so much from system to systems. And this is because, in a way, they describe what the system should actually do. But one way I like to think about them is that invariants are the things that you check for when you're doing manual testing of the system. So that's what I like to do. I like to test it and just try to analyze what is it that I'm actually looking for. So the invariants in the case of the form builder, well, I definitely check that after adding a question to the form builder, it should appear in the list. And when deleting it, it should disappear from the list. And also when I'm doing more thorough testing, I see that after creating a questionnaire, the resulting questionnaire should be completable. And I'll get back to how this is done later when I show you the implementation. Now, there are definitely more to the form builder than just these three invariants. They are not enough to describe the whole system, but it's a fine place to start. So now that we know what are the invariants we want to check, we need to define the model in a way that enables us to actually test them. And remember that the model is the second implementation of your system that we use when validating the test. But the method I'm using for stateful property testing, we also use the model while generating the commands. So we need to consider what information we need when generating as well. We definitely need to know that a new question has been added or deleted from the list. So it should model that. And we also need information about what questions already exist in order to possibly delete them or add behavior to them. So let's keeping things simple and just put the questions in a vector for now. So this will be our model, a vector of questions. So I'm going to use a library called Stateful Check, which is written by Carlo Sancanaro. You don't have to use a library to do stateful property testing in Clojure, but I like to use this library. And it does much of the heavy lifting for you when actually running the test, but it requires you to define the commands, how the commands are generated, and how they are run. So without going into too much detail on this, each command goes through a series of steps while being generated and run. And these steps are the ones that I show you here. And we start by defining what will be the initial state of our model. And then the framework starts generating more commands. And for each command, it goes through these steps in the square, where the first step, it looks at the model state, and it lets you decide, OK, I have this command and I have this model state. Should I keep going with it, or should I discard it and try something else? And I'll show you an example of that later. But the next step is the arguments step. It's where we generate the arguments for the command. And then it's the precondition, which is the same as the requires, only it also has access to the generated arguments. So we can choose to discard this command at this step as well. And now, conceptually, at least the way I like to think about it, is the next step is the command step. It's where we actually run this operation against the system. Now, stateful check works a little bit differently. I won't get into the details of that. But conceptually, it runs against the system now. And then conceptually, we update the state of the model after that, using the result from the command. And the last step is to validate the result, and we do that in the post condition. And if everything is all right, we do this over and over again until we have generated a long series of commands. So we now should know enough to see some code, I think. So I'm going to start with defining what should the initial state look like for the model. And as we decided earlier, this would just be a vector of questions. So it looks like this. And now to define the commands, I'm starting by defining the command for creating a new question for the form builder. And in stateful check, commands are just hash maps containing keys for all the relevant steps. And here I define the command step, which adds the question to the form builder, returning the question ID, and it also returns a list of all questions after adding the new question, because we will use that information later in the post condition. And as we can see, this command needs one argument. It's a hash map that takes a question type and a question label. So knowing that, coming up with our argument generator should be relatively easy. And don't worry if you haven't done property testing before, but this is what the generator looks like. What this one does is that it returns a hash map with a type that could be one of these elements in the list, and the label, which is a non-empty string. And for the next state, we use the return question ID from the command and add it to our model. And in the post condition, we check that the resulting form that we got from running the command has the same questions as we have in our model. So this is our first command. And if you want to, we can already use this in the test. And we will do that. And to do that, we need to first wrap it in a specification map, which is also where we do the setup for the form builder, and it's where we define the initial state. And it's also where we declare which commands we want to run against the system. And to run it, we put it in just a regular Clojure test and call it specification correct, which is the stateful check API for running the test. And when we run this with just one command, we get no failures. So that's pretty good. So let's continue adding more commands. And the delete question command is pretty similar, so I'll skim past it a little bit. But this one also uses the require step, which, as you remember, it lets you choose if you want to continue with the command or discard it. So this one checks that there exists at least one question in the model. And it uses, in the arguments generator, it picks one of the questions in the model that will be deleted. And the command deletes it and returns a list of questions, just as when adding a new question. And the next state does exactly the opposite of adding a question. It removes the question from the model. And in the post condition, does exactly the same as adding a question. It checks that the questions in the model are equal to the questions in the system. So let's continue. The last command that I wanted to put in this test was to add simple behavior to the form. And this one requires at least 2 questions to already exist in our model, which is because in order to have a behavior, we need 1 question and 1 value, which will be the condition for our behavior. And we also need at least one question that will depend on a condition. So this is the command. It takes 3 arguments, 1 question ID, 1 value, and another question ID. And then it returns the entire form, which we'll use in the post condition later on. So now we know what arguments the command needs. This is how the arguments generator looks like. It looks a little more complicated than the other ones, but it does exactly what I just said. It picks 1 question from the list of questions, and then it generates a random string for the value in the condition, and then it picks yet another question, but ensuring that it's not the same as the first one. And in the post condition, we use the return form from the command step, and we check that it is completable and that all fields are visibleable. And those helper functions are a little complicated, so I won't show them now, but the gist of it is that they try out every possible combination of values in a form and try to fill out the form, and then they check that at least one of them is able to save and it's valid, and that if we test all of them, then all questions should be visible at least once. So now let's add these 2 commands to the specification as well. And now, when we run the test, we are met with this report, which is the information that stateful check gives us when the test fails. So we have a failure on our hands. And it shows us information about what happened. To the left, we see the order of the commands being run. And we see that we ran 9 commands during the test. And just to the right of that, we see which commands it was and what arguments were generated. So you see that we created some questions, we added some behavior, we deleted 1 question, and etc. And just to the right of that, we see the result of running the command, but I have cut it off since it's not so important for now. What is more interesting is what stateful check shows us underneath that, which is the smallest case after shrinking. So we went from 9 different commands to only 4. And the commands are as follows. We create a new question, and then we create another question, and then we add the behavior, making the first question depend on the second question, and then add another behavior, making the second question depend on the first question. So we have a circular dependency, which causes that no matter how we fill out this form, those 2 questions will never be visible. Well, actually, the form crashes when trying to render this, but stateful check catches that as well. So now we're already at the point where we got the stateful property test up and running, and it's giving us sequences of commands that's causing failures in our system. And the next step, of course, is to fix this bug. And after that is just adding more commands and adding more complex commands, making sure that all the important parts are being covered by the test. So in our test, we are always adding the simplest kind of behavior, just 1 condition and 1 question that depends on it, but we can also add behavior with multiple conditions and multiple dependent questions. So what would happen if we added that? Well, we get more bugs, it seems, which is good. We catch the bugs, so it's good. We have now, however, come to the conclusion of my presentation. So what systems benefit from stateful property testing? Well, those are the stateful systems that integrate many moving parts or are talking to a database, for example, yet that are easy to model at a high level. Those are good candidates, but also simpler systems, such as the form builder, which is basically just data being passed around and transformed in memory. It can also benefit from it. And you may notice that I didn't really use the model that much when validating the result in the test that I showed you. I mostly used the return value from the command and checked the invariants. But this is also fine. You don't have to use the model really extensively. And we can find the commands by looking at what are we doing when we are working on the system, preferably from a user's point of view. And we start with the simplest one, and we just most common operations, then we keep on adding more bit by bit. And we can find the invariants by analyzing what are the things we are looking for when we're actually going into the system and testing it manually ourselves. And they might seem trivial at times, but this can be a good thing because it makes them easy to reason about. And the model, it should do what the system does, but at a high level, and it's a second implementation of your system. And to find the model, you can look at what are the commands you want to generate, what do the commands you want to generate need in terms of state, and what do the invariants need in terms of state. And I want to finish up with a good quote by Frank Hebert, which states that stateful property tests are particularly useful when what the code should do, which is what the user perceives. That's simple, but how the code does it, which is how it's implemented, that is complex. So that was a lot of stuff to go through in 20 minutes. And frankly, there's a lot more stuff to learn on the subject. If you want to learn more, you can check out these links. The top one is for the book that the quote was from, which is really good. It came out earlier this year. And you should also check out Stateful Check, which is the library I used. And also, Eric Normand has a new course that came out recently. And he goes through all of property tests and also stateful property tests, but he doesn't use the library, so it's another way of doing it. And you can also send me an email if you have any questions. And I also put the QR code down to the right, which is a link to a Mingle group where we can chat if you want to try it out. So thank you for listening to me. The code?
Yep, thank you.
The quote. Oh, sorry, not the code, the quote. Right. Right, I think there was a question there.
Yeah, the making of the model, like that, in a way, duplicates your system might sound challenging. Would it be possible in some cases that you actually use your system without making the model? You just call the system, perhaps mocking some behavior, and then test it, instead of building another model.
Yes, and that's one way of doing it. Usually, the way it seems is that people use the model very extensively. But like I showed you here, I didn't really use the model much. I used it mostly for generating new commands. So yeah, you can definitely do that.